Okay, so if you look at this one, you will see that all we need to do is plug in and rearrange. The concentration is the Henry's law constant times the pressure. The millimeters of mercury cancel. We're left with our answer in molarity, 0.0375 molar. Yes? Oh, you got a 4 and I got a 5. Obviously, you are mistaken, right, class? Yes? Good answer. No. What is the difference between 4 and 5? Don't tell me 1. He got 0.0374. I got 0.0375. Why is that? I rounded somewhere along the way. I might have rounded doing something. But remember, what is the true beauty of using significant figures properly? It's all the digits you're sure of and one with some uncertainty. So if I do the key and I get 375 and you get 374, how much credit do you earn? Full credit, right? And I'm not sure what happened in this one because we were only multiplying 2 numbers. But I don't know why I rounded and I can't go back and say, what was it, 374 something? 0? 08? Maybe I went dyslexic and didn't see the 0. I don't know. And I saw that 8 and rounded up. But anyway, all the digits you're sure of and one with some uncertainty. When we do longer calculations, you'll see more variations like that. But it doesn't matter. Okay. So in the first couple of examples, we knew the Henry's law constant. Sometimes we don't. So we can convert to a 2-point form if we don't know the constant. We know in Henry's law that the concentration is equal to the Henry's law constant K times the pressure P. So C divided by P is equal to the Henry's law constant. Now, we know that some situations, C1 over P1 is equal to the constant K, and some other situation, concentration 2 divided by pressure 2 is equal to K. If these two things are equal to the same thing, then they're equal to each other. Therefore, C1 over P1 equals C2 over P2. So this is the 2-point form of Henry's law. So we can use this when we are changing pressure conditions for the same setup. Let's look at an example of this. The solubility of nitrogen gas in water at 20 degrees, again, information that doesn't go in our calculation, is 0.0150 grams per liter when the pressure is 580 torr. What's the solubility at 800 torr? Well, now you'll notice I have a different unit here, grams per liter. We can use any units for pressure and any units for concentration. They just have to be the same unit. So I know C1 over P1 equals C2 over P2. You can rearrange this. You can write down the variables. You can just put the numbers in. I always like to pull the numbers away from the words. So C1 is equal to 0.0150 grams per liter. P1 is 580 torr. Make sure you get the pairs together correctly. C2 is my unknown, and P2 is 800 torr. So now I want to solve for concentration 2, so I rearrange. C1 P2 over P1 is equal to C2. Some of you might like to just write the numbers in and cross multiply on your calculator, and that works fine as well. So now, once we have this, we can go ahead and put in our numbers. Original concentration, 0.0150 grams per liter, times 800 torr, divided by 580 torr. That's equal to my new concentration, C2, 0.0207 grams per liter. I can keep 3 sig figs, and I add in the units grams per liter because I like to earn full credit on my quizzes. I'm very competitive. Okay. We have time for you to do the next one. Go ahead and do the next one at your seats. Wait a minute. Here it is. It's at the top of page 12-7. Go ahead and try this one at your seats.